So we have a small remote control car. The mass is 1.6 kg. It was moving at constant speed v, 12 meters per second in a vertical circle inside a hollow metal cylinder that have a radius of 5 meters. So this remote car will going to perform circular motion whereby the radius of the circle will be 5 meters. So what is the magnitude of the normal force? The normal force is represented by N, exert on the car by the wall of the cylinder at point A at the bottom of the vertical circle and at point B at the top of the vertical circle. So in order to determine the normal force that exert on the car, so we have to draw the FPD for the remote control car at position A and also position B. So let us consider point A, position A first. So at point A, so because the car have mass, so for sure we understood the car are going to have weight acting downwards. Okay, so W equal to mg is acting downward, and then the car is in contact with the surface. So perpendicular to the surface, we are going to have normal force acting. So by referring to the FPD that we draw, we can see very obviously at position A, the normal force is pointing towards the center of the circle, but then the weight is pointing away from the circle. So these two forces are going to provide the centripetal force that enable the remote control car to perform circular motion. So we are going to have summation force along the y-axis equal to Fc. So normal force is pointing towards the center of the circle. Weight is pointing away from the center of the circle. So we are going to have N minus weight equal to Fc. So this Fc can relate with the mass of the car and also the linear speed of the car, whereby Fc is mv squared over r. So we arrange the equations. We can calculate the normal force exert on the car, in which it is mv squared over r plus weight mg. Then you can pause the video and do the substitution of the value. So mass is 1.6, the linear speed of the car is 12. The radius of the circle will be 5, plus with mass 1.6, g is 9.81. Okay, so do the calculation, you will get the normal force acting on the car at position A should be 61.78 Newton. Then question B, we want to find the normal force exert on the car at position point B. So again, we are going to draw the FPD, what force is acting on the remote control car at point B. So for sure, the weight is always acting downwards. We have weight always acting downwards, and the remote control car is in contact with the surface. Perpendicular from the surface, we are going to have normal force. So we are going to have normal force. So by referring to the force we draw on this remote car at position B, we can see very obviously the weight and also the normal force both are pointing towards the center of the circle. I repeat, both the weight and normal is pointing towards the center of the circle. So now we are going to have N plus weight equal to Fc. So this Fc can relate with the mass and speed of the car and also the radius of the circle, whereby Fc is mv squared over r. Then we want to find normal force, so we rearrange the equations. So we are going to have normal force equal to mv squared over r minus weight minus mg. Then we put in the value. Mass is 1.6, the linear speed is 12, the radius of the circle is 5, and then the weight mg of the car. Then you may pause the video to do the calculations. So if you calculate correctly, you should get the normal force at point B should be 30.38 Newton. So class, you can see obviously, at point A, the normal force is greater. That's why we will feel heavier at position A. At position B, the normal force exerted on the car is less, whereby it's only 30.38 Newton. That's why normally we will feel lighter at the top of the circle. Okay.